Here we have two congruent triangles. We're going to still work with similarity though. Let's kind of see what it would take to deal with similarity. So we're going to start, they're congruent, but I'm going to move this, I'm going to slide the green side down a little bit. Notice that the triangle inside now gets smaller, but look what happens as I slide it. I start here, I leave it at the same rate, in other words, the same slope. And as I slide it, since it has the same rate, the yellow decreases at a constant rate, the blue decreases at a constant rate, and we come down to where it's nothing. So constant rate, moving down, I move it to here. Oh wait, constant rate. That means this ratio will remain the same as the original ratio. Okay, I started here. Okay, move it down. I moved it at the same angle, indicating the same slope, indicating the same rate. So they decreased proportionally to the blue and yellow here. So the blue and yellow on the left decreased proportionally to the blue and yellow on the right. Oh wait, yellow is to blue in the small one as yellow is to blue in the big one. The sides are proportional. Oh, hey, that works nicely. Let's try it and see if it works for another side. What if it works with the green, with the yellow being the one to change? I bet it will. What you think? Okay, so now we have two that are congruent. All the sides with the same slope. We're going to move it so that the slope stays the same. In other words, the rate of change stays the same. The ratio stays the same. So as I slide it to here, the blue gets smaller, the green gets smaller, but the angle stays the same, the rate stays the same. What do we have here? Little blue is to little green, as big blue is to big green. Ah, it's proportional again. It worked. Okay, well, what if it's the blue one that I'm moving? The blue one. Which one did I move before? Anyway, the third one. It'll be the same thing. So I'll move the blue one. I hope that one I did. Okay, there we go. Same deal. We start with congruent. Everything's at the same angle, at the same slope. As we move it keeping the slope the same. Thus the rate of change is the same. Thus the green decreases at a constant rate. The yellow decreases at a constant rate. As it comes down, it maintains the same ratio. The same ratio in the small is to the large. Green is to yellow in the small as green is to yellow in the large. Oh wait, all three sides are proportional. That's how we get that the sides, they're all proportional when all of the angles or rates stayed the same. In other words, it's a shortcut. We can find that that two triangles are similar given that each pair of sides are proportional. It means the angles are the same. Another way of saying that. Okay? So conceptually, that's how we do it. The side similarity theorem. Notice we'll call it side, but we'll put this little similar sign out to the side of it. The other one, side, is for congruent, and we'll just keep calling it side. And now this one we'll put side, knowing that they're proportional, and it's the similarity. Okay, while we were doing that, I hope you noticed that as we did it, one angle always stayed the same, and the sides stayed proportional. The two sides making that angle stayed the same, sides and angle. So if I talk about the original and the smaller one, really, once I get that the rate stays the same from here to here, rate is indicated by slope, which translate to angle in the triangles. That means that really all of the angles are the same. So it's enough to say that the yellow and green are proportional if the angle they share is the same. They'll stay the same. So this is another shortcut that we have, and it's side, angle, side. Let's look at where we are to now. What works? Let's look at our old congruency S's and A's. We had side, 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 angle, side, angle, side, angle, side, angle, angle, side, and then angle, angle, angle. That's all of our S's and A's. We're not counting the hypotenuse leg. And note, of these, all of these worked for something, but for congruency, angle, angle, angle didn't work. Well, do these work for similarity? Yes, we have that side, side, side works for similarity. Remember, you've got to have proportionality if you don't have your whole triangle. Okay, and you're trying to do it with a shortcut. This only has one side. Is there any way you can make a proportional statement with one corresponding side? No, you can't. It's not going to work. You've got to have two sides to make it work. So angle, side, angle doesn't work. And angle, angle, side only has one side, so it doesn't work. There's no way to make a proportion if you've only got one side that's the same. But side, angle, side, which we just saw, does work for similarity. And we know that angle, angle, angle works for similarity. And we know the shortcut that angle, angle also works. So relative to all the ones that we're used to with congruency, all the angles, or two is okay. But if you're going to do one of the other shortcuts, you have to do two sides, or you can't make a proportion. So it's just not going to work. Some of these. Okay, the side, side, side. See if we can find these similar. What do we have? Remember, all three sides would have to be in the same ratio. So 8 is to 7 as 7 is to 6. That's not right. So it's not going to be this one. I'm going to find out if the other one's this. Okay, 8 is to 4. Yeah, that's half. As 7 is to 3.5. That's a half. As 12 is to 6. Yes, the first one, the one on the left and on the right, are similar. The one in the middle is not similar to either one of them. Okay, how about side, angle, side? We have an angle between two sides that may be proportionate. It's the same angle. Let's see if it makes a proportion. 10 is to 15 as 6 is to 9. Yeah, that's times 3 over 2. 10 is to 15 as 6 over 9. If you write them, they both reduce to 2 over 3. Okay, so the factor is 3 over 2. How about this one? We have the same angle, and we have sides that might be proportionate. Let's see, we'll take the long ones and the short ones. Long is to long, as short is to short. 24 is to 18, as 10 is to 8. That's not the same. So these are not similar. Let's look at another example or two. How about the bow tie? There we go. They do have an angle between the sides that are purported to be proportional because we don't have to know what it is. They're the same because of vertical angles. So will it make a proportion? 27 is to 21 as 18 is to 14. You have to make sure you match them up correctly. 27 is to 21. Okay, that reduces to 9 to 7, right? As 18 is to 14, and that reduces to 9 to 7. So yes, it is proportional, so these two triangles are similar. Remember when you write your similarity statement to make sure that you list them in the same order. And here we end this lesson.